Bismillahirrahmanirrahim. Assalamu alaikum, sir. My name is Mehrun Nisa Yaqub, roll number 30, and the topic of my presentation is synthesis of bismuth oxide nanoparticles by Sol-Gel method. In this presentation, we will talk about the introduction, the literature review, objectives, methodology, conclusions, and references. First of all, we will discuss about what are bismuth oxide nanoparticles. Bismuth oxide nanoparticles are spherical in shape and they have high surface area. So they are categorized as high surface area oxide and they are magnetic nanostructured particles. And they typically range between 20 to 80 nanometers and their average particle size is 100 nanometers. Bismuth oxide has been investigated extensively because of its applications, its optical and electronic properties such as refractive index, large energy band gap, dielectric permittivity, their photoluminescence, and their photoconductivity. These properties make bismuth oxide an interesting candidate for the applications in the field such as optoelectronics, optical coating, and the gas sensors, etc. Now we will discuss about Sol-Gel method. What is Sol-Gel method? The Sol-Gel process is also regarded as wet chemical method and is used for the synthesis of variety of nanostructures, especially metal oxide nanoparticles. And in what happened in this process? In this process, a molecular precursor is taken and is dissolved in water or alcohol, and then it is converted into gel by heating and by stirring. If we are dissolving the molecular precursor in water, then we will call it hydrolysis. And if we are dissolving the molecular precursor in alcohol, then we will call it alcoholysis. Bismuth oxide nanoparticles were prepared by this Sol-Gel method, and the overall process basically involves three steps. First is the formation of homogeneous sol. Second is the formation of gel. And third is the decomposition of the gel to obtain the raw powder. And then the nanocrystalline materials were obtained after calcinating the powder at 500 degrees Celsius. Now we will talk about the literature review. In recent years, synthesis of bismuth oxide nanoparticle has been recently reported by using chemical method, for example, co-precipitation, hydrothermal techniques. These are used and has been confirmed to efficiently control their morphology and the chemical composition of the prepared powders. In recent years, green synthesis of nanoparticles have also got a lot of attention because of their applications. Their application in the field of medicine, in the field of biology. What happened in this process? Basically, bismuth oxide nanoparticles are prepared by using the mentha palladium aqueous extract, and they are heated at 90 degrees Celsius and are prepared after 24 hours. And the product was categorized by using UV visible spectrophotometer, Fourier transform, infrared, XRD, SEM, TEM. What happened in this process? Firstly, mentha palladium leaves were gathered and they were washed thoroughly by using double distilled water. The double distilled water was used to remove the dust particles, and then it was approved by herbarium and university. And finally, the leaves were cut into fine pieces and then dried in the presence of sunlight. Uh, for the preparation of aqueous leaf extract, 20 gram of mentha palladium leaves were taken and they were dissolved in 200 ml of double distilled water and then boiled at 90 degrees Celsius for 2 hours. And then the leaf extract was cooled at room temperature and then filtered by using Whatman filter paper. Then, for the green synthesis of bismuth oxide nanoparticles, 2 gram of bismuth nitrate was dissolved in 10 ml of water and then was heated at 90 degrees Celsius and was mixed with 20 ml of mentha palladium aqueous extract that we prepared in the last step. And the both were mixed at 90 degrees Celsius under constant stirring. So the UV visible spectrophotometer results showed that the bismuth oxide nanoparticles were prepared after 24 hours at 90 degrees Celsius, and the schematic representation also shows that 2 molecules of bismuth nitrate were taken and were dissolved in aqueous extract of mentha palladium leaves, and then as a result, bismuth oxide nanoparticles were prepared. The result sample was then washed for several times with double distilled water and then dried in a vacuum. And then to remove impurities, the product was heated at 550 degrees Celsius for 5 hours to remove all of the impurities. What was the objective? Objective was the green synthesis of bismuth oxide nanoparticles, and their antibacterial activity was also observed using UV visible spectrophotometer. And the second objective was their structural characterization. Then there is methodology, how bismuth oxide nanoparticles were prepared by using soil gel method. Uh, Bismuth nitrate and citric acid were used for the preparation of bismuth oxide nanoparticles. In this process, a known quantity of bismuth nitrate 5 pentahydrate was dissolved in nitric acid solution. First, it was dissolved in nitric acid solution, and then it was mixed with citric acid in a molar ratio of 1:1. Then the pH of the solution was adjusted to 3, and in order to prevent the agglomeration, a small amount of PEG 600 was also added as surfactant. Sorry. And then the solution was stayed for 2 hours, and then soil was done. As we discussed earlier, that the soil gel method involves 3 steps. First is the formation of soil. Second is the formation of gel, and then there is decomposition of gel. First step is completed, the formation of homogeneous soil, and then the soil solution was heated to 80 degrees Celsius for 3 hours to form a yellowish gel. Then the gel was decomposed at 120 degrees Celsius in an oven. The gel initially started to swell and then fill up the beaker with foamy precursor. This foamy precursor consists of homogeneous flakes of very small particles that consist of bismuth oxide nanoparticles. Structural characterization. There exist 5 polymorphs of bismuth oxide, namely monoclinic, tetragonal, body-centered cubic, and triclinic. XRD was employed to categorize these powders. The sample, first of all, the sample was scanned in the 2 theta range of 4 degree to 60 degree for a period of 5 seconds in the step scan mode. Then the diffraction pattern gives peaks that correspond to reflection planes of the monoclinic structure of metallic bismuth, and a small fraction of unidentified phase S was also observed. Here you can see different pictures that were taken using SEM. These are the SEM micrographs of thermally treated bismuth particles. In the first picture, it was heated at 200 degrees Celsius. In the second picture, 500 degrees Celsius. In the third, 800 degrees Celsius. In the first picture, as we can see that A exhibit a pseudo-spherical morphology. Particles in the A picture have pseudo-spherical morphology, but these particles begin to form agglomerates when the temperature increases up to 800 degrees Celsius. As you can see in the third picture, temperature is 800 degrees Celsius. After the thermal treatment at 800 degrees Celsius, the size of the particle has changed to microspheroid. So we can see that in the picture A, they have pseudo-spherical morphology, and in the picture C, they have microspheroid morphology. Then here are some references from where I collected this data. That was all for my presentation. Thank you very much.